Okay, so in order to solve limits in 1.5, you need to understand properties of limits and how they're used. We understood them in tables, we understood them in graphs, and now in functions and equations. There's a lot of strategies that we can use to solve limits. Easy ones, like these three, are very straightforward. Sometimes people have difficulty with these ones because they expect the difficult method that I'm going to see on the next board. But when you have regular polynomial functions and you have to find the limit, I mean, it's a polynomial function. You can just plug the number in here. So I can just, it's really, what I really want to say is it's the limit of each of these, right? So I can find the limit as x approaches 2 of 3x squared, of positive 4x, and of negative 1. So this ends up being, what you know it to be. So it's 3 times 2 squared plus 4 times 2 minus 1, and this just equals 19. So the limit of this polynomial function as x approaches 2 is 19 because it's a polynomial function, right? It goes forever. It's continuous. Left and right, it's going to be the same, or it's all good. Rational functions, however, not continuous, right? We know there's going to be asymptotes somewhere. We might have to factor to find those asymptotes, but we don't really have to deal with that right now because if I just plug in negative 1 into this is like saying it's like saying the limit. And, you're going to see the use of what I'm doing right now later on. So I can just find the limit of two polynomial functions. What's the difference? This is a polynomial function. This is a polynomial function. Together they make a rational function, but that doesn't matter. So if I just plug in the negative 1 into the numerator, I'm going to get negative 1 squared minus 5 times negative 1 plus 2. And I'm going to plug in negative 1 into here. This is not undefined. I put this in my calculator. I'm going to get negative 2 as an answer. So the limit as x approaches negative 1 is negative 2 because negative 1 is clearly not an asymptote. It's not going to be an undefined if I plug it in. So rational functions, pretty easy. Root functions, same idea. I can plug in the numerator and the denominator. I can find the limit of the numerator, of the denominator, whether I separate it like this or not. This is what the property of a limit is. It doesn't really matter. As long as you realize that it's substitutable, you're good to go. So this is just going to be 5 squared over 5 minus 1, and it's the big root of 25 over 4, and this is just 5 over 2. Okay, really easy to find the limit. What we have to look out for is when we get indeterminate form. When we are dividing by 0, bad. So you'll see some examples when we have dividing by 0 and some strategies that we take to avoid those things. Okay, so for questions like this, you can see right away that if I plug in 3, I'm going to get something over 0. If I plug in 0, I'm going to get something over 0. So I can't find the limit like I did in the previous 3 examples. I have to do stuff. So what kind of stuff do we have to do? Well, for instance, in a scenario like this, I can factor that numerator. So I can just say that this is x plus 1, x minus 3 up top, over x minus 3. So over here, I am going to factor. That's one of the things that I can do when I have something that's undefined. Okay, if I want to be proper, I'm going to maintain this, and these cancel out, and I'm going to be left with x plus 1. If I plug that in, I get 3 plus 1. My answer is 4. Really, really easy. Factoring. This example, if I plug in 0, there's nothing to factor here, right? You've seen this before in another lesson. I think it was 1.2. But the only thing I can do here is rationalize. So over here, I'm going to rationalize. Okay. And remember, rationalizing means multiplying by the conjugate plus 1 over root x plus 1 plus 1. Okay, there's nothing else I can do here. I can't factor this. I can't do anything. So I have to multiply by the conjugate. Now, this gives me squared and squared. So this is x plus 1 minus 1. So take a look at this difference of squares. Over x, root x plus 1, and this is the limit as x approaches 0. Okay, so take a look. This root x plus 1 squared is just x plus 1, and 1 squared is just 1, and it's a difference of squares. Now, I can simplify the numerator. 1 minus 1, so I have x, and you already see that x, just like the h's disappear. I can now cancel those out, and the limit as x approaches 0 of 1 over x plus 1, sorry, that was too much, plus 1, if I plug in 0, I'm going to get 1 over 2. So, couldn't plug in 0 here, but I know that if I approach from the left and the right for this function, my limiting number is going to be 1 over 2. Okay, so here I rationalize. Okay, there's one more difficult question that I'm going to discuss. Okay, so for a scenario like this, we don't even know what this is. I know this is the third root of x plus 8. It's not just a square root. But when something gets complicated like that, and more specifically, I have a third root or something to the exponent 3, we have to use substitution. Now, substitution becomes a very common skill or tactic, you can say, to solve these questions. So what we do in the substitution step is we actually set the complicated thing, x plus 8, x plus 8 to the 1 over 3. We're just going to set this equal to u. Okay, because look what happens when I do that. Watch this. So now I'm going to find the limit as x approaches 0 of just u minus 2 over, I can't really say x because it has to be in terms of u. So, problem. I have to solve for x over here in terms of u. And this is something that I always have to do. So what do? Well, I know that u3 is going to be x plus 8. I have to find the cube of both sides to get rid of that 1 over 3. And now just bring over the 8. And now I have a value for x that I can plug in over here. Now, if you've noticed this already, this is, yes, difference of cubes. Not difference of squares, difference of cubes. So I can actually expand that now. So I've unlocked something to do. I couldn't do anything here. But now I have something to do. I have u minus 2 over, if this is difference of cubes, this is just u minus 2, and then square, just change the signs, 2u plus 4. Okay, now these cancel out, and I'm left with, anytime I'm canceling out something, it's probably a great thing. Notice over here, this is a problem. My equation is in terms of u, but this is in terms of x. Okay, so all I can do over there is I can plug in 0 into x over here to see what I get, and I'm going to get u equals 2 if I plug in a 0 into x. So when I say x approaches 0, I can also say u approaches 2. These are the same thing. So I should have actually said as u approaches 2 over here, because I can't have x approach 0 over here. It doesn't make any sense. So I'm just going to erase this and say as u approaches 2. Well, I'm going to plug that in. 2 squared, 2 times 2, 4. My answer is 1 over 12. Done. Okay. Substitution looks complicated, but all I'm doing is I'm taking the thing that I don't know what to do. I can't multiply by the conjugate here because it's a third. It's not a half. It's not a square root, sorry. So because I can't multiply by the conjugate, I can substitute, solve for x, and now I have variables for u and x. Now when I plug these in, I can do math. All I'm trying to do with these tactics is to do math. I can't do math here. So I do it over here. And now I can do more math. I can plug in u is 2, and I can get 1 over 12, and I've now found the limit, which was, it looks like a pretty hard question, which it is. You're going to see it on your test, and a lot of you are going to screw it up, but it's not that hard. Properties of limits. Done.